Okay, so I already gave away the notation part here. You little geniuses are way ahead of the game. The notation is probability of B given A. That means the probability of B given A. So when you see that notation, you got to go, all right, that's the stuff that I know is definitely happening or already happened, and so now I'm looking for this to be the success out of the situation where that happened. So that should go like this. The conditional probability formula is probability of, I'm going to switch these around, all right, just so it's in, alphabetical order, I guess. The probability of A given B goes like this. Let's look at what happened here. What did I put in the top with this given thing? I went to 19. 19 was here where I had male and pierced ears. That's an and kind of a probability, right? So it's going to go, this is a fraction now, the probability of A and B, okay, and then it was over something. What was it? It was over a 90. Now, how did I get that 90? That was the probability of dudes, the probability of males. And so probability of males is one of those things. That's right here. That's the conditional given part. So it's over the probability of the conditional part, which in this case would be B. The probability of A given B has to have a denominator of the B thing happening, because that's what I was told happened, so that's now the new denominator. And then the A and B is kind of with a two-way table. It's the intersection in there. Okay, so in words, this is the probability that A and B both occur, like, a guy and pierced ears, right, over the probability of the given condition, right? So this is your actual formula right here. I want you to know that. This is me just kind of, making words make sense. Okay, so here's the chart again. Now, instead of asking you probabilities I already had before, I'm going to give you some new ones. Look, I've got the given thing in there. Find the probability of B given A. Well, that's the one we already did, right? Given that you got a dude, find the probability that the person has pierced ears. So it's out of dudes, so that's out of 90, and that's the probability of the conditional part. And then it's A and B in the top, so dudes and pierced ears is 19. 19 out of 90. Technically, since I called these probabilities, this is what's really going on here. You ready? Watch this. It's really 19 out of 178 for the probability of A and B to happen. And in the bottom, it's the probability of finding a dude, so that's really 90 out of 178. But don't all of you guys know enough about fractions that those 178s would cancel and I get 19 out of 90? Okay, the probability of A given B. Let's see what that means. The probability that I pick somebody who's male given that I found somebody who has pierced ears, right? Given I found somebody who has pierced ears. So all of these no's are out of it. 75 is out, 178 is out. It's just these people here. So out of 103, what's the probability that I pick a guy? It's 19 out of 103. The probability of B given C. Okay, so that means I pick a person with pierced ears given that I found a girl. That's going to be a high probability probably, right? So the given part, female, let's go find how many females there are in this study. There's 88. And then find the probability that she has pierced ears. So that's going to be a girl with pierced ears. That's 84 out of 88. That's a pretty high number. Technically, I should probably make those all decimals so we can compare them. They make more sense. But I just want you to get the idea here today. The probability of C given B. The probability that I pick a female given that the person I picked has pierced ears. That's different from this. This is the probability that I pick somebody with pierced ears given that it was a girl. This time it's different. What's the probability to pick a girl given that I found somebody with pierced ears? So the given part, the pierced ears part, is out of 103. There's 103 people that have pierced ears. And the probability that I find a girl then is going to be 84 out of 103. That is a smaller probability than that. Think that through for a second. Okay, on page 332, we've got an example on the Titanic disaster. This example goes on for a while. We're going to use this one a few times. The author really loves this example, and I think it makes a pretty good point. 332. Here we go. Two-way tables and conditional probabilities. I saw that movie, The Boat Sinks. In 1912, the luxury liner Titanic, on its very first voyage across the Atlantic, struck an iceberg, sank, and Leonardo, he just kept saying Rose a lot. That's all I remember about that movie. Anyway, some passengers got off the ship in lifeboats, but many of them died, sadly. The two-way table gives information about the adult passengers who survived and who died by class of travel. Okay, here we go. Let's have an uncomfortable society conversation. People taking first-class tickets, people with second-class tickets, and people with third-class tickets. If you saw the movie, you know how they all had much different lifestyles on that boat. There's people who survived and people who died. Suppose we randomly select one passenger of the adult passengers from the Titanic. Define these events. F is a first-class person, S is survived, and T is a third-class person. Find the probability of T, it's a third-class person, given that they survived. Okay, so before I look at this, given that they survived, so that means out of 442 survivors, what's the probability of the person who was third-class passenger? It's going to be 151 out of 442. So I'm going to look down here, and they have 151, out of 442. That's a 34% chance. If I went and looked at all the people that survived, there's a 34% chance they had third-class tickets. Okay. Part B. Given that the person chosen was not a first-class passenger, what's the probability that he or she survived? Not a first-class passenger, so you're out. So that's out of these people right here. I got to add this up, 261 and 627. So look, that's what they do right there. And then what's the probability that they survived? Well, then I'm going to take this 94 and this 151, and I'm going to add those together. And given that you were not a first-class person, you only had a 28% chance of surviving that wreck. Okay, there's a couple of conditional probabilities to help you out. Well, look, I got another one. Page 333. I'm doing a lot of reading today. A survey of all residents in a large apartment complex reveals 68% use Facebook, 28% Instagram, and 25% do both. We've seen this kind of thing for, I think, the Venn diagrams and two-way tables, right? Suppose we select a resident at random. Given the person uses Facebook, what's the probability he or she uses Instagram? Now, I could make a two-way table. We did that. Or I could make a Venn diagram. And if I make a two-way table, it's like the Titanic thing. You could just, put your numbers on top of your numbers. But here, look what they did. They're going to use the actual formula. The probability that they like Instagram, given that they use Facebook, is going to be the and part, Instagram and Facebook. Well, you have a number for that up here. 25% do both, so that's just your numerator. See what I mean? And then the bottom is the probability of the given part, the Facebook part. So you can use the formula and just go 25 over 68 and get your answer a lot quicker than taking this thing and writing out a whole two-way table, getting your two-way table, and then figuring out what your denominator is and then going from there. The formula sometimes can be more helpful than the table or the Venn diagram. You just got to choose given what your information was given to you, right? So like I said at the beginning, this isn't about your ability to put numbers in a formula. All of you can do that. You're all very good at that. This is going to be about, can you read it and see what the right direction is to go? Okay? We're going to our last page for the first day of this stuff anyways. Hey, it's a check your understanding. Look at that. I'm tired of reading stuff. It's your turn to read some stuff. Here's your check your understanding right there. This is about people using snowmobiles and an environmental club. We may have seen this one before too. So read your check your understanding. Do 1, 2, 3. I got a strong feeling you guys are going to do well with that. So go do your check your understanding. I'll come back and go over the answers, and we'll finish this out and be done for today.